All right, so again, Chris Lorenzo. I've been a front-end web developer for as long as I can remember, which is over 20 years. And I am based out of Philadelphia, so I'm in the United States. On the East Coast, there's Philly. And recently, probably the last 3 or 4 years of my career, I've been working on TV apps. And it was very interesting when I found out that TV apps can be developed with a web browser. On RDK devices, we have WPE, which is WebKit Embedded. It's basically Safari. If you use other TV engines, you're probably already familiar with, they have Chromium or a version of WebKit on there. But I found this to be really amazing that you can develop on your desktop inside of a browser, and then that just kind of works on a TV. But one of the downsides, of course, is performance. Performance is so horrible on these TV devices because they are basically, let's say, the most affordable chips that TV manufacturers can buy to lower the cost of the TV. So they're like $20 chips compared to your smartphone. They are much slower. So we struggle with getting really good UIs to get even 30 frames per second on these devices. This is like a Raspberry Pi 4 picture, which is usually faster than a lot of TV devices. And so when we first started, when I was working at Comcast, I no longer work at Comcast, but when I was, we tried building this screen here in HTML and CSS. And we got it built, but we had to remove all the animations, all the extras and shading and drop shadows. Like, it was just bare bones. And even then, it barely rendered. And a lot of that was because we were doing this on an X1 box, which is even slower than slow. And it was just painful building this. And one of the reasons for this is when you understand HTML and CSS and what the browser actually has to do, like, it gets really complicated. And it's amazing how performant browsers are today. And they've obviously gotten a lot better over the years. But there's still this need to take your HTML tree and actually convert it to a DOM tree. Then they have to go through your CSS and convert that to a CSS object model. Then they kind of bring the two together and do rendering and layout. And this process is actually pretty expensive. Very quick on our desktops, but on a slower device, it can be noticeable. And if you want to go into details about how that works, Chrome has like 6 or 7 pages talking about how browsers render. They go into the CPU, GPU, memory, everything, rendering and layout. And it's become even more complicated as we have new things like Flex and Grid. Like, rendering is a very complicated process. And this is where Lightning comes into the world, is for building high quality TV apps. And Lightning was this idea of, what if we don't use HTML and CSS and we use WebGL for rendering? So all browsers have a canvas tag in there, and you can do WebGL, which is the new version, or there's Canvas 2D. And so Lightning came about to kind of avoid the whole DOM and have to rendering on these low performant devices. And in some of our benchmarks in comparison, we get a lot more frames per second than you would building a similar app with HTML. And a lot of this really is in the animations. If you have a static page that's just rendering once, like HTML and CSS is probably good. But if you want like a fancy UI experience, using something like Lightning is a great choice. So I'm going to go into a little bit more about Lightning. This was a Lightning 2 TMDB app that was open sourced, and it kind of shows you how to build one with Lightning 2. But we're going to momentarily talk about Lightning 2, which was the previous version. And some of the downsides of it was, when I started using it 3 or 4 years ago, it was a monolith. So one big framework. It didn't have reactivity, which was the most annoying part about using Lightning 2. Was you would get new data from the API, and then you would have to call patch to update the UI, and you'd have to specifically tell it where to patch and update things. And like web developers for many years are used to two-way data binding, that you change a variable and it just automatically reflects in the UI. But that was not the case with Lightning 2. Also, it was a proprietary, unique framework that you had to learn. It was not like React or Vue or anything else. So it was like this, like, what is this doing? I spent a lot of time reading the source code to figure out how things work. And then the other part is, like, when you develop for TVs, you want to try to support Chrome less than 38, and Chrome less than 38 doesn't even have fetch in there. So it is an old browser and technology. So Lightning 3 was a complete rewrite of Lightning 2 from the ground up. Like, took the same concept but rebuilt it to further along with new ideas, new technology that's out there. And so Lightning 3 broke apart the renderer, which is the thing that does the drawing to the canvas, from the framework. And there's a new text rendering system in there. There's dynamic shaders, which is the ability to put multiple shaders together to do one draw call versus multiple draw call. Batch rendering, so we do one single draw call to render multiple things. And multi-threading was actually just recently removed because the idea of ThreadX was you could render the canvas on an off-screen canvas on a separate thread and then draw on the main screen. But a lot of browsers don't fully support that yet, and probably most TVs won't have it for a few years in the future, so no reason to have the overhead. But the renderer, if you actually download the project and open up the examples, you will see different things that you can do with the renderer. So this was, as we were building it out, as the team was building it out, they created this little example page of things animating and moving around and an elevator going up, and you're just like seeing the development happen. You're like, this is great. But you wouldn't want to use the renderer directly. So this is what you would have to do with this example page: is you call renderer.createNode. You give everything X, Y positions, what's your width and height. The source is if you want an image, and what's the parent node. And you can set z-index, but everything on that screen is calling renderer.createNode and passing in all these parameters to render it on the screen. And similarly, there is renderer.createTextNode. These are our two primitives: creating a text node and creating a node. And text node is exactly what you think. This is how you would put hello world on there, and it would render on the screen. And then it has a very primitive animation API where you can call animate and tell it what node you want to animate and start the animation, set duration, X, Y. But this is very similar to CSS transitions, except a lot more fine-grained in what you can do with it. But obviously, like, this doesn't work for most people because we need to build something complicated, like a complicated UI like this. And in order to do that, you wouldn't want to use the renderer directly. You need a framework. Like, you want to use a framework. So the Lightning team spent a whole bunch of time building out their own unique framework. They released it as Blitz. It's been a few years in development. And if you look at the syntax, it is essentially Vue.js, Vue 2. It's mimicked on that. And they built a custom framework because they thought it would be faster or better. And there's so much uniqueness with TV apps that they needed their own thing. But I kind of went against this, and I said, you know, this is yet another framework syndrome that we have in front-end development, where everything is a new framework, and that's kind of painful for developers to learn all this new stuff. So the idea of the renderer was, since it was broken out from the framework, it allowed you to bring your own framework, BYOF. And this is where SolidJS comes into the picture. So here comes our hero, SolidJS. And so I started researching Solid and finding a bunch of articles by Ryan Carniato. He is the author and creator of SolidJS. And I really like engineers who are disciplined enough to write, you know, how they reach that part, like, of I want to build a framework. And he has a series of articles about why he did it, what were the things out there. And I like that he didn't set out to write a new framework. He acknowledges that most frameworks are pretty similar nowadays, and nothing is really new. Like, he took JSX, he took the concepts of React, but he got rid of the virtual DOM and he made it a whole lot faster. And he recognizes that, you know, when you build a framework or you build a library like SolidJS or Vue or Angular or even Blitz, like, it's not just the framework that you need, right? You need the ecosystem around it that makes it a full-fledged framework. You need lots of adoption. You need people who are contributing to it, giving it new ideas, etc. And that's what makes it a framework, because the more people you have using it, the better the framework will be in the long run. And really, he summarizes like the one thing that you really need from a framework is rendering. Like you want to take markup and you want to be able to render it on the screen and do manipulations of that stuff. So he introduced SolidJS after he is like a framework author or guru who has read all the different framework source code and had all these new ideas. But he has an article on introducing SolidJS, and this came out 2020, but I think the framework's been out for almost 6 years now. But this is an introduction. And one of the things that is the reason why I really went for SolidJS over even React is it's the fastest. And he summarizes this. It is the fastest. He compares it to all the other frameworks. And, you know, if you're working on these really low-end devices, like performance is your number one thing. Like you need it to be the fastest framework, which is why I was like, okay, it's the fastest. Let's test that out and actually check. And it's really snappy, which I like. Additionally, it's fully featured. So if you're coming from Vue or Angular or React, like all the features that you're familiar with there also exist with SolidJS, and you get them out of the box for free. So I don't even know what half this stuff is, like fragments, portals, context suspense, error boundaries, lazy components, async and concurrent rendering. A lot of those features are also in SolidJS with Lightning. You don't get event delegation, because I think that's like click handling, that's kind of built in, and server-side rendering and hydration doesn't really work because we're all on a canvas tag. But all those other features are actually there. Suspense is there, lazy component loading, context using portals and fragments. So let's look a little bit at SolidJS. The big thing that SolidJS introduced was this idea of signals, where you can create variables like this count, and it's a signal so that when you read that variable inside of an effect, like create effect, anytime that variable changes, it will re-trigger the effect. And this makes it so that it's very fine-grained in the framework or the library, that as you're using this and you're changing variables, it's updating the one place the variable is used, rather than using a virtual DOM, which requires a whole diffing algorithm to then figure out what needs to change on the UI. This, as soon as you change a variable, it's updating the UI, and there's no diffing algorithm. So it's very, very fast. And it keeps track of exactly where it needs. There is tons of documentation and examples for SolidJS, which I also really like, because I don't have to write any of it myself. It's just available. You can learn Solid, and it applies to Lightning. So let's actually talk about how this applies to Lightning. Like, where does Lightning fit in with SolidJS? Like, SolidJS is a great library for building HTML and DOM and CSS. But Ryan Carniato came up with this universal render target. And I talked to Ryan on his stream, and he said, like, one of his friends asked him to do this. He was like, well, why? Oh, he wanted to build his own framework, and he's like, don't do that. Like, we can update this framework to just render whatever you want. It doesn't have to render DOM and HTML. And he kind of summarizes it like components in Solid are just functions. If you never use a native element like the div tag or a tag or image tag, and don't call render, we never need to import DOM APIs. You can build whole systems with Solid just using components and the reactive systems. Like, here is Solid rendering WebGL. And I was like, whoa, this is great. This is exactly what I want to do. And so I was able to take SolidJS and their idea of universal rendering. This is a little dated on how you actually use SolidJS, but it's still kind of similar. You import render and text, and you get hello world. And in order to do this, SolidJS has these functions. This is all you need to implement. And if you implement create element, create a text node, replace text, all these different things, you actually tie into SolidJS's universal renderer. And if you notice, most of these things are just creating a DOM tree. You're creating elements, and you're saying which one's a parent. You're inserting other ones inside of there and making a tree. And so if we take a look at how this works, here's hello world. We have a view tag. We have a text tag. We can set a color, hello world. This is rendering to canvas. But under the hood, this is being translated into create component of a view tag and passing in props, which is the color. And we keep looking down this. This is essentially create element and set prop. And everything is just, these are function calls then going into SolidJS or coming from SolidJS. And we just replace these with actually calling the renderer, the Lightning renderer, with, instead of creating DOM elements, we're just calling render create node. So when create element happens, we call create node. We pass in the same properties that we're receiving from the JSX markup. And likewise, when you call create text node, we're calling create text node. And that's as simple as it is. It was pretty simple. It takes a while to get going, probably about 2 weeks. But once I tied in all the things just started magically working. And one of the things that I really like to emphasize is text rendering. So text rendering in Lightning 2 was very, very difficult. And the reason for that is you want this, like you want to write this kind of markup and you expect this to be rendered. Like title the page, you can format it nicely, it's a paragraph, there's spacing in between. But if you've ever studied text rendering is really, really difficult. In fact, there's this article that I found, Text Rendering Hates You. Really great article, I recommend reading it. But rendering text, how hard could it be? As it turns out, incredibly hard. Because you don't know, like when you write hello world, what is the width of hello world? You don't know until you render it on the screen, and then the Lightning renderer will tell you this is the width. So then that makes it really hard. How do you do layout if you don't know the width of the elements ahead of time? But luckily we have Frank, who was part of the Lightning team. He wrote this signed distance field, SDF, text renderer, which makes the fonts and rendering in Lightning 3 way crisper and way more performant than they were in Lightning 2. So I'm really excited about the new text because the text just looks fantastic. So continuing on, there was some ideas that I added to the SolidJS integration with Lightning. One of those is Flexbox. So most CSS developers are familiar with Flex, but you can do Flex Start, Flex Ends, like all the different Flex properties. There's margin support in there too, so you can move boxes a little extra. And that also made it so that this text rendering, the framework or SolidJS, my integration with it under the hood, is waiting for all these text nodes to render, getting the width and height back, and then laying out all the text using the Flex, which is pretty difficult, but I did it to make it easier for developers actually using this. There's also this idea of padding, which you have decorators with SolidJS, so we can do use padding and set top, right, bottom, left on there, so that after the text renders, we can draw a box around it. So this is a common thing that TV app developers want, is a PG-13 with a box around it, or an HD. So doing that is actually very hard because you don't know the width of PG-13. So this actually renders the text, and then once it knows the width, it creates padding around it to render the box of the parent. And so using SolidJS and Lightning 3, you can build an entire TV app. So this is open source demo app. And we'll go into this. I'll show this in a few minutes. But there's this whole trending. And this is the actual page for what you just saw. All of this at the top is the Solid API. I am using exactly what Solid offers. All their create signals, all their create resources, which is how you do fetch to get API data, and even using the SolidJS router. So everything just works out of the box. You can use any of the Solid primitives. I'm using their keyboard handler, their mouse event handler. Like you just grab the open source stuff and it kind of all works for free. And then when you're writing the template syntax is also JSX. All the control flows that they offer from the SolidJS website, and it's documented, they just are available. So if show works, which is their if statement for template syntax, you have for loops, you have index loops, you have portals, you have fragments. It all works out of the box. So the syntax is very clean and very simple to pick up. And then all these additional attributes are documented on the SolidJS integration. So there's like the ability to set focus. The row and column add key handling for up, down, left, right. So these are kind of components that I built to make it easier to actually build these screens. And I'll demo this in a second. But just to wrap this up, there's not just SolidJS. I actually spent time integrating with Vue.js as well. So Vue.js has the same custom render API. So all the work that I did to integrate with SolidJS, I was able to integrate with Vue.js in about a day or 2 days. And then I just had to spend time like rewriting the components for column and row and key handling, et cetera, to be like Vue.js syntax. But this is currently underway too. It's already open source. It's already working. I just had to do a little bit more cleanup before I release it as a 1.0. And we are almost ready for questions, but before we use questions, I'll just show off the URLs and show off the demo app a little bit more just so that people can see. So here is the home of the SolidJS demo app, and I already have this up, but this is a TMDB app. And I actually have mouse support too. So for Magic Mouse, LG remote TVs, this is available. So you can actually hover over things. And then it doesn't work too well when you switch between the two. So I'm going to reload. So we can do keyboard moving left and right. We can go into a screen. And I like to emphasize how fast this is. So we can go into here. Luckily, Chrome has recently introduced a 20x slowdown for CPU throttling, which I'm like, you are the best. So this is now a 20x slowdown. I'm going to click reload. And so that renders in under 4 seconds or so. Like there's very little happening on the main CPU thread to get this rendered. So it is lightning quick, I like to say. And here's the same demo app with Vue.js. So keyboard handling is working. We have side navigation. Most of Vue.js demo app is working and the library is working. You could get started with this. It will just be nicer once I release the row and column component and getting some of the things worked out completely. But that is all I have to demo. We ready for questions or? And I will post the links in the chat. So there's Lightning TV / Solid demo app if anybody wants to check it out. And you can actually go to, I'll put the repositories here.